Again, grade 12s, hope you have a great one. Today I want us to focus on projectile motion. We have this statement here. A group of learners set an experiment to determine the height or age of their school building. They released a tennis ball from point A at the edge of the roof of the school building as shown in the diagram below. Point B is 2 meters above the ground and the ball takes 0.125 seconds to cover the distance from B to C, which is B to the ground. So C is a reference to the ground. So ignore the effects of air friction. The very first question says, write down the magnitude of the rate of change of velocity of the ball. What is the rate of change of velocity? What is this rate of change which we must write down? The rate of change of velocity. What is it? The rate of change of velocity. The rate of change of velocity is the acceleration. So you know that the acceleration, which is the rate of change of velocity, a rate of change of velocity is equals to the acceleration. So that is why the formula to calculate the acceleration is acceleration is equals to change in velocity over change in time. That's what you have to understand. There's something that basically they're asking the acceleration there. Okay, the magnitude of the acceleration of the ball. The acceleration of the ball there. Remember that the tennis ball, the ball was released. Okay, it was not thrown by initial velocity or whatever. So that the acceleration would be 9.8. Okay, yes, even if it was being thrown, so mean that it was being released in that case. Okay, yes, so mean that the acceleration there. So for number one, let me just write it here. It's 9.8 meters per second squared. Okay, yes, 9.8 meters per second squared. All right, that's how it goes. Try to make you understand that one. So let's move to number two. So number two says calculate there 2.1. Okay, so moving to 2.1 now. Let's just write 2.1 here. Let's just use this side. 2.1. All right, 2.1. So we have to calculate there the height of the school building. Let's calculate the height of this school building here. Let's work on that one, guys. All right. How can we calculate the height here? All right, the very first thing that I picked there is that we should find the velocity of the ball at B so that we can be able to calculate. Because I think almost everything from B to C is given. The distance as well as the time. 2 meters distance was the time, which is 0.125 seconds. All right, so in that case, I'd like us to first find the velocity of the ball at B. So the velocity, by us finding the velocity of the ball at B, what we're going to look for is that let's first find that one. Okay, the velocity of the ball at B. How are we going to find that one? We know that at B, we're going to assume that the initial velocity of the ball at B is 0. The initial velocity of the ball at B is the one that we're required to calculate up until it reaches the ground at C. So at C, we know that it took 0.125 seconds. Okay, yes. So let's find the velocity of the ball at point B. That's it. That's what I'm trying to say. So we know this one is given. So change in y is given there. So change in time is given there. So we're looking for VI is equal to we don't know. We're looking for, so VF is not given there. Okay, final velocity. So in this case, let's find the velocity of the ball at B. So let's use this equation of motion, which is change in y is equals to initial velocity plus, I like to say plus always, multiplied by change in time plus half acceleration change in time squared. So remember that now. Okay, let's just say upward is positive. I like to always take upward as positive because it makes things much easier for me. So upward is positive in this case. All right, so upward is positive, so mean that if we're moving from B to C, that's downwards, so mean that this is going to be negative 2 meters is equals to VI change in time, which is 0.125 seconds plus half negative 9.8 meters per second squared multiplied by 0.125 squared. Let's patch that. Okay, let's first say negative 2 is equal to 0.125 VI to make things easier for you. So plus that. So I think that's going to be negative. So let's say half 1/2 negative 9.8 0.125 squared. All right, the answer for me there is negative 0, let's just write that one as it is 0, okay, negative 0.0765625. so we're taking that one to that side, so it becomes so we say negative 2 plus 0.0765625, which is going to be equals to negative 1 9234375, which is going to be equals to 0.125 initial velocity. So we divide by 0.125 divide by 0.125. Let's cancel that, so our VI will be equals to, so let's divide by 0.125 and our final answer will be negative 15.3875. That's how it goes. So initial velocity there. The reason why it is negative, remember that we chose upward as positive. So the ball is moving downwards at point B. So that is why it's negative. Alright, it's opposing the motion that we've chosen to be positive. Alright, so in this case, that's how it goes. So meters per second. Alright. Remember, we're not calculating the initial velocity, we're calculating the total distance of the building H. Okay? Alright. When the ball was at A, it was dropped by the learners who were pursuing that experiment. It was dropped. Okay? It was dropped. It was a free fall up until to point B. Okay? Up until to C. Okay? But at point B, we know that it's negative 15.3875 meters per second. Alright. How we can use this this velocity at B so that can find a way forward to calculate the distance of the building? The very first thing that we have to do then is to calculate the final velocity at C. That's the way that I can try to do that one. So the final velocity at the final velocity at C, at the ground. All right. So which formula I'm going to use? It's VF is equals to VI plus A change in time. So our final velocity we're looking for is equals to initial velocity is from this point to that point is negative 15.3875 plus negative 9.8, right? Negative 9.8 change in time is 0.125. All right, so final velocity will be equals to, press that all in the calculator, so plus negative 9.8 0.125, and the final answer there will be negative 16.6125. Again, the reason why it is negative, it's mainly because the reason why it is negative, it's mainly because we chose upward is positive, but the ball is moving downward. That is why its opposing the motion is negative. That's why our final velocity is negative. All right, we're moving forward now. We know that the distance, oh wow, guys, we didn't see all the time, so sorry about that. Let's just move like this. Okay, let me just explain this. Okay, so you know that from point A to point C, from point A to point C, you know the time you know the time it took. Yes or no? No, we haven't calculated the time, but I think you can be able to calculate the time it took because we have the final velocity now, right? We have the final velocity, but I don't think the time is much more useful in this one because we know the final velocity, and we're looking for change in y. Okay, so the formula that we're going to use there is vf squared. Okay, is vf squared. Let's just use it in this way. Let's just okay, let's just continue on this side. So vf squared is equals to vi squared plus 2a change in y. So our vf squared there will be negative 16, 6125 squared is equals to 0 squared plus 2 negative 9,8 change in y. All right. So here we're going to have negative 16. Oh, so sorry. So let's just punch that in our calculator. Negative 16, 6125 squared. So the answer there will be 275,9751,563, which is going to be equals to 0 plus negative 19,6 change in y. Alright, let's divide by negative 19,6 divide by negative 19,6. Let's consider that, and our change in y, in that case, change in y will be equals to, so we divide that by negative 19,6, so it's going to be negative 14,08 meters. All right, so and therefore we can't leave it as negative, so it's going to be 14,08 meters. And the reason why it is negative is mainly because, remember that we are calculating from point A up until to point C, up until it reaches the ground. So that is why this is downwards. Remember, we chose upward as positive, so this one is going to be negative. That is why from A to C it comes up as negative. So in all, our change in y, our the distance of the building, or the height of the building is 14,08 meters. Hope everyone is with me. Let's move to the following question. Following question says that was 2.2. So sorry, just all right, just give me a few seconds so that I can do this very quick. So sorry. Okay, there was a mistake happened there. All right, so in this case now, what we can do is that we want to calculate 2.2. okay, 2.2. So we want to calculate 2.2. Let's just say like this. So we want to calculate 2.2. So 2.2, time it takes for the ball to reach the ground. The time it takes for the ball to reach the ground. Remember that we know the final velocity, we know the initial velocity. So in that case, let's use final velocity is equal to vi plus a change in time. So the final velocity is negative 16,6125 is equal to initial velocity. The ball was dropped by the students or learners, so 0 plus negative 9,8 change in time. The time is what's the time? All right, we're calculating the time, by the way, change in time. So negative 16,6125 is equals to 0 plus that, so it's going to be negative 9,8 change in time. So we divide by negative 9,8, divide by negative 9,8. All right, let's patch that in our calculator because this cancels this, so we have to change in time, which is going to be equal to negative 16,6125 divide by negative 9,8. So the answer there is going to be 1,69, which is 1,70, okay, 0.70 seconds. All right, remember this is rounded off from 1,69 because I know this might be useful at some point. 5-3 so that you can get the appropriate answers. Okay, exact appropriate answers. So 1,695153,061. Okay, all right, that's our time. Highly correct. Okay, let's move to 2.3. 2.3 says we have to calculate the velocity with which the ball strikes the ground. The velocity which the ball strikes the ground, you just calculated that one. But if ever you didn't use this way of calculating the height of the building, which is, I believe, is the longer, you're not going to have this phase here. It's just going to be much shorter. So how can you calculate that? So you can simply say that because you know the time, right? You know the time, you know the initial velocity. So Vf is going to be equals to Vi plus a change in time. So our final velocity there will be Vf, which is equals to Vi. Vi, what's our initial velocity? Initial velocity is 0 plus that's going to be a problem. There's going to be a problem there. So all right, there will be no problem there. So that's going to be negative 9,8 because we chose upward as positive, multiplied by 1,6951, our time 53061. So our final velocity will be equal to 0 plus that. So 0 multiplied by negative 9,8 multiplied by that. So that's how it goes. The answer is negative 16,6125. Therefore, our final velocity will be 16,61 meters per second. That's how it goes. And that's it. All right, let's move to number 3. Number 3 asks us to sketch a position. I hope everyone can see that. Okay, I hope everyone saw here. Okay, yes, because I have a mistake of not showing it because I'm much more concentrated on the paper. Okay, so sorry about that. So number 3, sketch a position versus time graph for the motion of the ball from the moment it was released until it strikes the ground. Use the ground as the 0 reference point. Indicate the following on the graph. Very important, the height from which the ball was released, the height, okay, of which the ball was released, as well as the time the ball strikes the ground. 3 marks, so that the shape will be also a mark out there. Okay, so that's number 3. Position time graph. You just write position time graph. Position time graph Okay, this is our time in seconds, our position in meters, or height in meters, whatever. So sorry. Okay, that's it, guys. I'm so sorry, guys. Okay, yeah, because he didn't see that, and I kept on making the very same mistake. Okay, yes, because I'm much more concentrated on the paper. Okay, yeah, so sorry about that. Okay, so all right, how many meters? Okay, so it was 14,08 meters above the ground. Okay, 14,08 meters above the ground, and it fell off moving towards the time there. The time it took, it was 1,70 seconds, and that's how it goes. The marks that we're going to awarded here is for the meters above the ground, height above the ground, being shown there, as well as the time taken by the ball to hit the ground, as well as the shape. Okay, yeah, but I'm not on scale, guys, please forgive me. And that's how it basically going to look like, and that's it. All right, and that's it, guys. Okay, yeah, so I mean that if ever you got this wrong, the height of the building as well as the time it took, you're obviously going to get the position time graph also wrong, which you're going to get 0 in that case. Please try to practice those kind of graph, because in some students, in my own experience, to students that have been teaching for years, it's a mistake that they keep on doing. Okay, yeah, all right, that's how it goes, guys. Have a great one. Cheers, keep on practicing. Bye.